see who's left in the room. How many students do we have left? Fair amount. From industry, how many managers do we have left? And then how many maybe boots on the ground? How many technical staff do we have? Okay, so this is for you guys, and hopefully it's going to inspire some of the students as well. Me and my colleagues are going to talk about computational design, which is perhaps an aspect of BIM management. To introduce ourselves, I'm Astrid. I'm Principal Computational Designer at Zutari. I have 10 years of industry experience in architecture and BIM management, and more recently, computational design. I come from a background, tax alumni, in architecture and computer science. We have Dr. Broekman, civil engineering computational designer at Zutari, with a PhD from tax in civil engineering and transportation. And then heading up our team down in Hermanus in Cape Town, and part of our computational design team working on the Middle East, we have James Abrey with a background in structural engineering. On our agenda for today, I'm going to give you a brief introduction. And we're going to talk about the synergy between computational design and information modeling. And we've specifically left out buildings, because we don't work in just buildings, we work in buildings and infrastructure, underground structures, tunnels, bridges. That's what we're going to talk about today. Andre will talk a little bit about developing our computational design workflows in practice. I will talk about a case study of bridges we did in Abu Dhabi. And then we will close off with capitalizing on new initiatives and spin-offs within the industry. You've heard many speakers over the past 2 days talk about the BIM paradigm. We've had many people also talk about ISO 19650. Zutari is currently undertaking quite an extensive initiative in certification and training in this space. And what we have found as BIM and computational design practitioners is that we can very quickly turn workflows into automations that help us increase the scale and complexity of projects quite easily. But one of the arguments we make is that we are not replacing human skill. And I think majority of the room has heard of ChatGPT, AI, and those types of things. So our focus is on augmenting the capacity that the humans in your firm provide. We look beyond the BIM paradigm of understanding why. Why do we do BIM? Why do we standardize? And we bring your attention to some research from Susskind and Susskind named the evolution of professional work. And what we find is that something that was perhaps a craft is now being standardized. And after it's standardized, it's systemized. And after that, it's externalized. It's given to another system. But the argument that we make is to focus on systemization before you focus on standardization. Why standardize? First answer why you're going to standardize something before you decide on how to standardize it.
And so going from what we've heard about the 9 stages of the BIM process, it's a way of doing. You do each stage, you move on to the next part. But we as computational designers and the CoDE thinking process is there so that we can find this unity between the BIM process and between the computational design process to reach that systemization that Astrid was talking about. And that can only work with the collaboration. We need both the BIM side with the 3D models and the data behind it. And if that data isn't standardized, isn't correct, then there's no way for us to do what we do and systemize it. We need those both links. And as Astrid was saying, it's that augmented process. And
there you go. Thanks, James. So we talk a lot about digital transformation within our organization as well. And we have a bit of a different take on it. So we found a bit of inspiration. For those that don't know, it's called the Gartner Hype Curve. So you'll see the curve there on the left-hand side. And it describes the typical maturity that you see for a particular technology. So using drones as a good example, around about 10 years ago, there was a lot of talk about drones and a lot of tinkering and research and development work. And at the peak of inflated expectation, everyone thought that all construction managers will one day be replaced in a few years and we'll just have all the drones swarming around on site. And eventually the industry went through some changes. Some companies became dominant, like your DJIs. And as we've seen during the last 2 days, it's now a normal part of our practice. There's regulation, there's training and certification, and it's now the status quo. Same can be said for things like Bitcoin, where that's also now a standard financial instrument, and there was a lot of speculation at the start. So how does this link with our digital transformation journey and BIM? So what we see typically in organizations, referring to the graph on the right-hand side, if you look at the dashed line, we typically come up with a cool idea or concept, or somebody writes a macro, what I've seen quite a lot, and we think it's a fantastic tool. It sits somewhere in the My Documents folder, and that person leaves, and it never sees the light of day again. So we did not really transform or benefit or utilize that inherent capability that was developed. How we see through this 4-part systemization process and how it enables and grows our digital capability and culture within an organization is to say, once we start talking about BIM, the standardization of it, and we start to systematize the different processes, understanding the inputs and the outputs that we need, we start undergoing that digital transformation journey. If we talk about externalization as computational designers, do we develop an interactive tool? Is it a Dynamo script? Is it part of another software package? How will the end user interact with that tool that makes their lives easier? If we succeed with that journey or process, that's when we gain this incremental digital transformation within our culture. But importantly, there's a human-in-the-loop automation. We're not in the business of just building buttons. Click a button and something happens. It forms a part of a much bigger process. The long-term benefit or yield that we do get from that, going forward, we can reuse a lot of the tools and skills that we learn and develop throughout the last few years, and we can keep on scaling that within the organization.
So from what Andre is talking about and from that process, we at Zutari have taken in the philosophy to allow us the opportunity to develop customized tools. So besides what Richard was saying earlier about using the tool to the fullest, when we reach that ceiling, when we reach that end point, there needs to be a tool or a process or engineers or computational designers to go beyond that, to use that hard work that we've already put into putting the data into the models, working through that BIM process to take us further and allow us to integrate those data pipelines to deliver that value-added service on much larger projects, which we find is happening all over the world. So now I want you to ask yourself this question. So what is the purpose and why even do this in the first place? So we have one example from a project that I've been working on recently, where we needed to manipulate a model, a Revit model, to take screenshots of various elements. And what Laan was saying earlier about data, it made me think that data was kind of like a joke. If you have to explain it, then it's not very good. So we have this model that has all this data behind it, and we can't go through the model and take the screenshots of the various zones that we need to, because in Revit you need to select and highlight, and through a manual process, there's a lot of steps that need to follow. And that process took about 35 minutes. But then using that data in the background with parameters that had those, the parameters in those elements that allowed us to select a certain element based on a criteria, we could use filters and a script and those things to move around the model much quicker. So initially we had 35 minutes to do 15 zones, so you can do the math. But then using the systemization process of manipulating the data behind the model, the data behind the BIM, we could cut that down to 10 minutes and actually deliver the project that we needed to in a much shorter space of time.
Thanks. And I take you over through to a project we completed in Abu Dhabi. This was a conception phase project. We had 6 weeks to deliver 20 bridges. The timescale in which projects are being delivered is being shortened dramatically, and without BIM, it's almost unachievable. What we decided to do was to look at the data structure behind what a bridge actually is. What we came up with for a project was we found that all the bridges were concrete reinforced bridges, footbridges. They all covered either a water navigation channel or a road. And they incorporated various bridge superstructures and span arrangements, although they kept to the same methodology overall. You can see between the two bridges that were developed, just as an explanation in this presentation, there were quite different and various complexities involved. And so this bridge on screen might seem to be the more complex bridge, but it was actually this one, in terms of data, that was more complex. What we found in our project was an underlying data structure that we could define in terms of, in this case, a JSON file, to use instead of heading straight into modeling. So what we found is we could define a bridge in terms of a collection of spans, piers, abutments, and bearings, for example. And they all followed the same methodology. So what you see on that side of your screen is the data structure that drives each and every bridge in the project. And the data structure was the same, even though each bridge was unique. What we then developed from that was a line model, for lack of a better term, we call it a stick diagram, of what the bridge looks like. And only after that was developed did we develop something called maybe perhaps your BIM model. At the end of the process, what we automated was the BIM process for each bridge. And what you see on the screen now is your alignment data, your substructure, your piers, your foundations, your decks, and your beams being built. Something that happened in the project was the engineering team provided one of the bridges backwards. And we picked this up quite late in our deliverable. But because of the system we designed, after we corrected the information that we were provided, we managed to update the BIM model and the drafting for that project within 8 minutes.
So still on the same bridge project, so because all of the data is in a well-defined human-readable format, it's a very versatile data source. So within half a day, there were some questions on the placement of the different elements, the numbering of the elements, and whether they conform to the standards that we required. And within half a day, we used Python to build a quick visualization tool to ensure that all of the data is represented correctly, everything is in the correct location, and importantly, that the bridge is in fact the correct way around. So touching a bit on the wider computational design culture, even though I'm a civil engineer by training, a lot of people think that I do lie about that fact. A lot of the postgraduate studies that I also completed at Tux is where a lot of this information and skill sets were developed, and we see a lot of application in industry. And the more and more we work with data, the more utility we start seeing for skill sets in programming to manipulate this data and effectively do that. And within the organization, we are also starting to develop a bit of a framework towards certification. So even though we might not be able to train yet within a university context for those skill sets, what information is available? And the best part of it, most of it is in fact free. So we take participants within the organization that wants to continue on this path. There's a good course from Cisco that provides a good baseline or foundational framework for Python in this case. We have boot camps at the office, whether that's engineers, modelers, or drafters. We provide them with the basics, and then we already have 2 people that's completed the credentials provided by the Open EDG Foundation to certify that you are in fact skilled in basic Python development, and we hope to continue the uptake of that. And as part of the wider organization, it's still a big cultural change. We're not going to train 2,000 people tomorrow to become programmers, but we're slowly seeing that permeate and diffuse within the larger organization. And James posed the question of, but why? What is the purpose what we do as computational designers? And I came across this pretty recently on the whole thing. We always talk about we must be more efficient and we must be more productive. But those are 2 terms of the same side of the coin. So productivity is the ratio of inputs to outputs. We want to increase the outputs. If you think of a factory, the more cars we can build, the more we can produce in the same amount of time. For efficiency, we're looking at reducing the input or the complexity that we need for the same amount of output. And from my viewpoint, a lot of what we're talking about BIM, standardization, reducing the friction that we have with all of these different data formats and interchange to do something with it. That's where a lot of the focus lies on the efficiency. If we start thinking about productivity, if we can produce more for the same amount of time that we spend to do that activity, the more profitable we are and the better value that we can deliver for end clients. We're currently involved with a large-scale project in the Australian market, and for me, that's where we see a lot of utility of these skills that we are developing in the organization. From an efficiency point of view, how can we do things faster? One of the most recent things that we've looked at, and we've talked a lot about the cost of these fancy computers that we need, and we realized we can start porting some of the software that we developed from a CPU to a GPU, and we can run what used to take 40 minutes last week, takes 3.5 minutes now. So that's an 11 times speed up of time that you no longer need to spend to wait for a computer. On the productivity side, how we develop or deliver more value to clients, we essentially taking a whole design process, an engineering design process, and instead of weeks or days that it takes to make modifications, go back to a client, have a meeting with them and tell them I can see you next week, we're bringing that down in a visual tool set, similar to what you've seen with the bridges, and we can run an analysis and design case in 5 seconds. What does that mean? They said in a meeting, we're in real time optioneering different ideas with the client, with their input and direct feedback. So it becomes a real-time interactive value addition to what we do, and the tools that we develop might not produce more products, but it does reduce the time that we spend to do that monotonous work to produce more options for a client at the end of the day. So food for thought on that one. And James?
And I just wanted to add one more point on the purpose as well, is there is a process to the BIM, or there is that BIM process, and there's a number of steps, and there's a methodical way of going about it. And sometimes it can seem tedious, and sometimes it can seem like, why am I doing this? And there's more admin, now there's more things that can go wrong. And the whole purpose, and another purpose that we're trying to get across here is that if it's done correctly, and if that extra time is taken up front, there's so much time that can be saved down the line. And when I started as a computational designer, one of the things that my managers told me was that he wanted to save 20% of the engineer's time. And now I had no idea how to do that because I had just started as a computational designer. But what I took that to mean and took that to heart for me was that I'm not trying, and as Astrid was saying, I'm not trying to replace them, not trying to get rid of them, but it's essentially trying to just get them home faster. And if we can make this BIM process a real, a standardized thing in everything, then we can do these extra steps of computational design, and it doesn't mean that we're going to magically fix everything, but it will mean that we may have some more time, either to go home earlier or be more creative and find more of those sustainable solutions that Thomas was talking about earlier. And so with all of that being said, it is true that in the next 20 years that everyone will probably know some sort of programming, and it's important that we know that so that we can develop those tools and get to that save time and that get home faster, as you would speak. And that is also the only way that we're going to be able to reach those high demands that clients are putting on us, that the world at large is putting on us. And again, when you're in your job and you're doing it and you're slogging through it, there's a lot of repetitive tasks. So when you see those tasks, think of what you can do to possibly make that faster and a lot less boring. And what we have tried to show here is that it can be done, and sometimes it's a lot of fun, and it doesn't feel like a job when you take those repetitive tasks and make them fun. So thank you for hearing us, thank you for your attention, and if you have any more questions, or if you're even just struggling on something, here's our contact details. Feel free to send us a message and we can help in whatever way we can. So thank you very much.